All right, let's talk about one of the coolest, most important ideas in AI right now, retrieval-augmented generation, or, RAG for short. The best way to think about it, it's basically like we're finally giving our AI an open book exam, instead of making it memorize everything.
But first, let's start with a question you've probably asked yourself if you've ever used a chatbot. Why is it that these incredibly smart AIs sometimes just make stuff up? They give you an answer that sounds super confident, totally plausible, and is just completely wrong. We call these hallucinations, and frankly, they're a massive headache.
And here is a perfect example of what I mean. On the left, you see a standard large language model, an LLM, saying some historical event happened in 1 year. But on the right, the actual fact-checked answer is a totally different year. Now, the AI isn't trying to lie to you. It just doesn't know any better. So what is going on under the hood here?
See, here's the fundamental problem. A standard LLM is brilliant, but it's like a student who's been forced to memorize thousands of books for an exam and then has to take it from memory alone. It's a closed book test. All its knowledge is just what it was trained on up to a certain date, so it's frozen in time. It can't look anything up. So if its memory is a little fuzzy or outdated, it's got to guess.
And this is where RAG just completely changes the game. It's the open book we've been talking about. Instead of only relying on that static internal memory, a RAG system does something amazing first. Before it even tries to answer, it retrieves fresh, relevant info from an outside source, and then it uses that new knowledge to generate a way better answer.
I mean, you can really see the difference when you put them side by side. A standard LLM, it's stuck with its fixed training data. But an LLM with RAG, it's plugged into dynamic, live databases. This means it's way less likely to hallucinate, because its answers are grounded in actual facts. It can even tell you where it got the information, which is huge for transparency. And maybe most importantly, it can access real-time info, so it's not stuck in the past.
Okay, so let's pop the hood on this thing and see what makes it tick. You've got your external knowledge source, that's the library. Then the system uses something called text chunking to break all that knowledge into bite-sized pieces. An embedding model then turns all that text into numbers, which gets stored in a super-fast search index called a vector database. When you ask a question, a retriever zips through that database to find the relevant info. That info gets added to your original question by the prompt augmentation layer, and finally, the LLM gets this new, beefed-up prompt and generates the answer. It sounds like a lot, I know, but it all happens in a flash.
So putting it all together, it's really like a simple 4-step dance. 1, you ask your question. 2, the system instantly goes and searches its knowledge base. Maybe a company's private documents or a live news feed for anything relevant. 3, it takes those golden nuggets of information and staples them to your original prompt, creating this new, supercharged version. And 4, it hands that augmented prompt over to the LLM, which now has all the fresh context it needs to give you a brilliant, fact-based answer. Now, it's worth knowing that not all RAG systems are created equal. You've got what's called naive RAG, which is pretty much the basic, straightforward process we just walked through. But this field is moving so fast. Now there's advanced RAG, which gets smarter about how it finds information, and even modular RAG, which lets you swap different parts in and out to build a more customized, powerful system. Okay, this all sounds really cool in theory, right? But where is it actually being used? Where does it make a real difference? Well, let's take a look at a place where being right isn't just nice, it's absolutely critical: a modern manufacturing floor.
Just imagine this for a second. A complex piece of machinery flashes some obscure error code. Instead of digging through a giant dusty manual, a technician can just ask a RAG system, hey, what's error E47B and what are the first 3 things I should do? The system can pull the exact procedure from the latest digital manual, instantly. Or it could query live inventory data to help optimize the supply chain. Or, and this is a big one, it can provide immediate life-saving answers about complex safety rules, right there on the spot. It's a total game changer for efficiency and safety.
So, RAG is making AI smarter, more accurate, and a whole lot more useful. But, and this is a big but, it's not a silver bullet. Once you connect an AI to the outside world, you also open it up to a whole new class of problems that we really need to think about. And probably the biggest new risk is something that has the pretty ominous name of RAG poisoning. Think about it. If the RAG system is taking an open book exam, what happens if somebody sneaks into the library and writes a bunch of lies in the books? That's RAG poisoning. Bad actors could intentionally feed bad data into the knowledge source, tricking the AI into spitting out answers that sound right but are dangerously wrong.
So in the end, it feels like we're trading one set of challenges for another.
Standard LLMs hallucinate and get out of date. RAG pretty much solves that. But now the quality of its answers depends completely on the quality of the data it can find. It can also be a little bit slower because it has that extra retrieval step, and the whole system is just more complex to build and take care of.
And really, that brings us to the big final question here. RAG is fundamentally changing AI from a sort of brilliant, sometimes unreliable know-it-all into a diligent researcher that has to show its work. But that huge shift puts an incredible new responsibility right back on our shoulders. If we're the ones building the libraries for these AIs, how do we make sure the books on the shelves are true, fair, and safe? That's the challenge we're all going to have to figure out together.